Hi, and welcome back to Wondering Wild. It's Wild Wednesday, and so we're going to talk all about the Arctic fox. Okay, so the Arctic fox is a small fox native to the Arctic regions of the Northern Hemisphere. Now, it has the scientific name Vulpes lagopus, and it's also called the white fox, the snow fox, the polar fox, all of the above. However, we're going to refer to it here as the Arctic fox. Now, one of the most unique things about the Arctic fox is that because it lives in one of the harshest environments on the globe, it has some really interesting adaptations to keep it warm even in those sub-zero temperatures. So we're going to talk about those first. So when you're cold, one of the mechanisms that we have is shivering. And so when you shiver, basically your muscles are contracting at a high rate, which can produce heat. And that's why we have the shiver mechanism. So you would imagine whenever you get cold, which for me is like 40 degrees Fahrenheit, you start shivering, right? Well, the Arctic fox is so well insulated, so good at staying warm in cold temperatures that its shivering mechanism doesn't even come into play until it's around negative 94 degrees Fahrenheit. That just kind of gives you a reference point on how well adapted this fox actually is. Now, one of the things that keeps it so warm is its very dense multi-layered pelage or fur. And now this fur is the most efficient at keeping an animal warm of any mammal. So even polar bears don't have fur quite as efficient as the Arctic fox. Another adaptation that the Arctic fox has is countercurrent heat exchange. Now, many animals have countercurrent heat exchange. A lot of marine mammals like dolphins and a lot of animals that live in cold environments. To an extent, we all have a bit of countercurrent heat exchange, but it's more pronounced in these animals that tend to be in cold waters or cold environments. Now, what countercurrent heat exchange is basically using the blood vessels' proximity to one another to keep the core temperature of an animal warm. So basically what that means in kind of layman's terms is when it's cold out, you want the core temperature of your body to stay high. So that means you're always going to have colder fingers and toes than you do kind of like your midsection of your body, which is where your heat is because that's where all your internal organs are. So you want to keep them warm so that they're running properly. And one way that this is done is through countercurrent heat exchange. So basic principle of physics is that when something warm and something cold come into contact with each other, the warm thing gives off heat and starts to warm the cold thing, whatever that may be. It's a basic principle. So what countercurrent heat exchange is using this principle to warm an animal. So you have blood vessels flowing towards the extremities of your bodies, like your finger, and you have blood flowing back towards your core. And if these two blood vessels come in close contact, so if they sit right next to each other, the warm blood that's leaving the center of your body and heading towards your fingers will pass in close proximity to the cold blood that's in your fingers and now traveling towards the center of your body, and it's going to heat that blood. So that means on a whole, your blood's going to stay warmer because you're using your core heat to warm the blood coming from your cold extremities. And so that's how countercurrent heat exchange will keep you warm even when it's cold. And they're going to have this mostly in their limbs, so like their arms, their legs, fingers, toes, and sometimes in their ears. Dolphins have it in their flippers. Now, another adaptation that animals in colder climates have. Ignore Lila eating in the background. She obviously only gets hungry when I'm filming. It's like a new thing. Oh, mom's filming. Must eat loudly. Anyways, so another very common adaptation for colder weather is shorter extremities. So if you lived in a very cold place, you would not want very large ears. And that's because the surface area of your large ears would release heat at a great rate. Now, if you lived in the desert, you would want large ears because you release heat at a great rate. So if you look at the difference between the fennec fox and the Arctic fox's ears here, you see kind of that adaptation. Animals in hotter climates tend to have longer legs, longer tails, and bigger ears, as well as maybe a longer snout. Whereas the opposite is true for animals that live in colder climates. They're going to have shorter legs, shorter tails, shorter ears. And that's because it allows animals in colder climates to conserve heat and animals in warmer climates to lose heat. So you're going to see that the Arctic fox has really small ears, and that's why. Now, another thing this fox has is kind of a round, compact body, which provides a low surface area to volume ratio. And basically what that surface area to volume ratio means is that animals follow a rule, and that rule is called Bergmann's rule. And what that rule states is that within a group of organisms, like foxes, okay, you're going to see that animals in colder climates are larger, while animals in warmer climates are smaller. And the reason for that is surface area to volume ratio. Okay, so surface area to volume ratio is very important because basically it just means the surface area, which is the outside surface of an animal or a cube, whatever you want to look at, is where diffusion and loss of heat happens, okay? It can only happen where there's surface area. Your volume is everything inside, so that's going to be the inside of the cube or the internal organs in the inside of an animal, okay? And that's where you want to stay warm, right? Or you want to cool that off, depending on the environment you're in. So things that are smaller have a larger surface area to volume ratio. So that means there's more surface area for every bit of volume. And things that are larger have a smaller surface area to volume ratio. Now, back to the Arctic fox. The Arctic fox also has hair on the bottom of its paw pads, which provide extra insulation against the ice. The last adaptation they have for the cold is that their fur actually changes colors throughout the year. So in most Arctic fox populations, the foxes are completely white in the winter to help them blend in with the snow. And then they change to more of a gray, kind of brownish color in the summer when there's less snow and it's more just ground cover like dirt, leaves, twigs, and melted snow, which is a really great adaptation to help them kind of blend into their surroundings. Now, even though we talked about this fox having small ears, that has not hindered its hearing at all. The Arctic fox has such good hearing that it can determine where its small prey, like a lemming or a vole, is under the ice to an exact location. And once it determines where that animal is, it does this really cute little pounce. Here's a picture of it. And then it kind of captures its prey. Now, like I said, they prey on small creatures like lemmings and voles, and they're actually pivotal to the cycle of lemmings and moles. Now, something really cool about Arctic foxes is that they actually form monogamous pairs. So during the breeding season, one female and one male stay together for the entire time, and they have this complex burrow system under the snow where they both raise their pups together. I hope you enjoyed learning all about the Arctic fox today and its many adaptations to keep it nice and warm in a very cold place. As always, my sources are found in the description box below, and if you liked what you saw, give it a thumbs up and subscribe to my channel so you don't miss any more videos. And as always, stay wild and never stop wondering.